I go up to this beautiful landscape. I'm on top of a mountain. We're taking this quantum sensor and bringing it up to a mountain and doing real-world applications with it. This project is, at the end of the day, a test of fundamental science. It's a test of Einstein's theory of relativity.
Clocks, they don't run at the same rate if they're tugged on by gravity differently. A clock here in Boulder is not going to run at the same rate as a clock that's sitting up on the summit of Mount Blue Sky. Gravity is tugging on them differently because they're sitting at different heights.
Imagine you and a friend each have a wristwatch on your hands and you're next to each other. These watches are going to agree. They're going to tell you that it's exactly 1:32 p.m. That's what time it is. Now say that you want to go on a hike to the top of a mountain, but your friend wants to stay home. So you go up, you hike up this mountain, and you call your friend and you say, hey, what time is it for you? Your friend says it's 4:31. Your watch says it's 4:32. And you're like, hey, wait, I thought our watches were perfect. Why is it telling us a different time? It turns out that both you and your friend's watches are both correct, and that time at the top of this mountain is actually different. So the further up you are, the faster time will tick. We're taking the most accurate watches that humans have ever built. They're based on this quantum sensor of an atomic clock. And we're taking one of these up to the top of a mountain and comparing the time that it tells us up there to the time that it's telling us down at some lower elevation. And that will tell us whether Einstein's theory is proved or perhaps there's some perturbation in that theory. And we would like to know that with this project.
Basically measuring heights by measuring the time offset between your clocks. And so we can use this as a way to understand the height differences, the different tug of gravity in different places around our Earth by using these quantum sensors.
So I'm working on these laser technologies that right now are being used for fundamental science. However, these technologies are very important for applications such as virtual and augmented reality, various forms of biological and chemical sensing for like environmental sensing. An experiment like this perhaps could open doors into new fundamental physics and a deeper understanding of our own universe.